So thank you for that lovely introduction. My name is Yasmeen Ahmad and I work for Teradata in the Think Big Analytics team. So I thought the presentation there was just so fascinating to think about the potential of where AI, analytics, deep learning, machine learning is going. And my presentation is kind of pulling now back into the commercial side of how our organizations leveraging some of these trends that we see, some of these buzzwords, some of the techniques behind the buzzwords and so on. So the team that I lead at Think Big Analytics consists of data engineers, data scientists, visualization experts, and very much we're working with companies around the world to look at complex analytical use cases in the everyday business world to see how do we leverage some of these analytical techniques to create value from everyday data sets that are being generated and collected by these organizations. So in today's talk, I will be looking at, can we really get algorithms, get code, get machines to help us with consumer interactions, with creating that customer journey, that customer experience that helps businesses be successful. So thinking back to actually how businesses started off, or back to kind of a smaller scale when it was local economies. If I look at the customers we work with retailers, telcos, we work with financial services, the big banks, and all of these organizations, these businesses, started at a point when it was much more local community-based. So you would go to your local branch, you would go to your local store, if you were going grocery shopping, etc. And when it was at that local scale, it was very easy for these businesses, or relatively simple, to have that customer connection, to speak one-to-one with consumers, to build a customer intimacy. So you went into the branch, the bank manager would know you, they would potentially know your family, they would know if there were any significant events happening. You could have that one-to-one dialogue and begin to personalize the service that you were providing, point customers in the right direction of the right products, the right services. But fast forward, if we look at today in the global economy that we operate, it's so much more difficult to have those one-to-one conversations because actually digitalization has introduced a whole set of new channels that our consumers interact through. So we've got mobile devices, we've got our digital websites, we've got call centers, we've got the web chat on our digital platforms. All of these channels are creating new ways for consumers to interact, but are also creating an interface, a barrier between a business and that customer. So through all of this digitalization, what's happened over time is businesses have lost that opportunity to have that one-to-one personalized conversation. They've lost that customer intimacy. However, what all of these channels do for businesses is they create data. And that data is a digital footprint. So when a customer does come and interact on your website, they do come and interact with that mobile app, they leave a footprint, they leave a data footprint that describes who they are, what they were doing. Potentially from that data footprint, we can begin to elicit what that customer was looking for, what was happening in that customer's life. We can look at their behavior, we can look at these interactions. So very much so, as organizations have begun to think about how they build those customer experiences, how they think about that customer journey, this data has become really important. So if we look at the kind of hype in recent years, and we go back to the Gartner hype cycle in 2014, you saw that big data was everywhere. It was in all of the newspapers, in the articles, in the blogs. Everybody was talking about big data and about collecting big data. So during the last 3-4 years, what we've seen is these large organizations have invested in big data platforms. They've invested in capturing all of those interactions that customers are having across channels. But actually, fast forward to today, and a lot of these companies are really struggling. These big data platforms, their data lakes, are not producing the value that they'd imagined. So many projects in the big data space are failing. So these are some Gartner statistics that say 60% of projects in the big data space typically fail. The number of data lakes predicted to be useless by 2018 is 90%. And a lot of this comes down to the fact that organizations knew that data was valuable. This data had insight within it, so they started building these big data platforms, data lakes, but without that business use case in mind, without understanding what do we do with this data once we've collected it. Because after all, collecting data has no value. Data is just bytes. It's just information stored in a big data platform, in a database somewhere. It's not until you perform analytics on that data, that's when you get insight. So if we look at the Gartner hype cycle, the most recent one from 2016, what we see is big data's actually completely disappeared. It's not moved to the plateau of productivity. It's not on that hype cycle anymore, because actually it's become a status quo. Of course you're going to collect big data. Of course big data should be collected, managed, etc. But actually what we see on that hype cycle today are terms like deep learning, machine learning, artificial intelligence. If you look at the blogs, if you read the articles today, those are the buzzwords that everybody's talking about. Because today there's that realization that it's the analytics that we apply on top of the data that creates the insight. And if I look at the industry and I look at some of the customers that we work with, those that are doing this the best today, those that are succeeding, those that are not in that 60% of projects that have failed, are the digital elites. It's the Ubers, it's the Facebooks, it's the Netflix, it's the Apples of the world that are not only using data to create insight, but they've actually monetized data. They've created whole business models that depend upon data. And these large companies, they're disrupting the industry. They're coming in completely unknown previously, the likes of Uber, and completely coming in and disrupting an existing industry. And the way that they're doing this, if you think about Uber, is you download the app and you order a taxi online. It's changing the experience. When you order that taxi, you know who the driver is who's coming to pick you up. You know the exact make and model of the car. You know what the license plate is. You can track that taxi moving towards you on a map. As you begin that journey, that taxi ride, you can actually see yourself as you move across that journey. You can track yourself. You can share that tracking with others. Uber has provided an experience to customers that was never available before. They've increased the transparency into that service like never before. And what's actually happening is that is changing customer expectations forever. These companies are changing the way customers expect to interact with businesses and large organizations. So for some of the traditional companies that we work with, the likes of the financial services, big banks, the retailers, they're now looking at how do we leverage data and analytics to be able to compete in an industry where you have these pure plays, these digital companies. So if we look at traditional organizations and how they've typically looked at customer experience or marketing, if you take a marketing function, they would have had a set of planning at the beginning of the year that looks at creating a campaign calendar. So I want to interact with my customers, I'm going to look at what products and services I have, and I'm going to plan my campaign calendar across the year so that I have a series of campaigns I know I'm going to run to help sell my products and services. But actually, the paradigm is completely changing today. A customer expects real-time interaction. So no longer is it acceptable to be pushing products and services to customers. Customers want to be heard. So organizations, as businesses, we need to be listening to those customers. We need to be looking at what their journey is. We need to be anticipating what need that customer has, and then placing a relevant offer, a personalized message, a personalized service to that customer. Because today, with all of these channels in front of a customer, they have so much choice, they will go elsewhere if the product, if the service, if the recommendation isn't relevant to that customer. But to enable these real-time interactions, to enable that one-to-one dialogue with a customer, it means you need to know when to interact with them, which channel, at what point in that customer's journey. What should the message be? What should the offer be to that customer at that point in time? So the who, the what, the why, and the when. And this is where data and analytics can come in helpful, because as we try and create these moments in a customer's journey, as we try and reach out and have these real-time interactions, it's data that can help us guide those interactions, that can guide us to when in that journey we should intercept. What offer should we put in front of that customer? And if we look at research, research shows us how important it is to get those questions right. So a recent study that was carried out by an academic institute looked at how important is that location. So if we were to give consumers a geo-targeted offer, how much better could that perform compared to a standard email offer? As they tested this, what they found is the geo-targeted offer that is taking into account the location of a customer when an offer is presented, that's 2 times more effective, 2 times better conversion rate than a standard email offer. So as they were exploring the location, the geo-targeted offers, they began to look at things like the location and the busyness of that location. So because we know we can geo-target an offer, actually for many customers, we can geo-target when they're on their daily commute back and forward from work. Should we target the offer when it's a busy time, i.e. the commute is busy, or less busy? So which is more effective? And in fact, what the study found is it is better to send an offer out when public transport is busy. The hypothesis being that on a busy train or a bus, consumers are much more likely to take out their digital devices and become much more engaged. Hence, an offer received at that point in time is likely to engage the customer better. So by just tweaking these levers, by tweaking the time, the point, the location, the environment of the customer, by tweaking the point at which we send out that message or that offer, we can hugely become more successful because we're hitting the customer at the right time. And Google describes this as meaningful moments. So they describe creating these meaningful moments within the customer journey where you're there, you're useful, and you're quick with the right message, and you're having that constant real-time dialogue with your customer. So if we reflect on kind of organizations and businesses, how do you create this meaningful moment? Analytics is not new for businesses. We can use data and analytics to create these meaningful moments, but actually we've been using data and analytics for a long time in businesses. If I look at some of our large banks, for example, they have hundreds of analysts in-house who've been working on analytics around customers and predicting if a customer has a need, etc. And typically, these analysts, these quants, they would work with data, they would look at that data, and they would build a model. So you might be building a churn model to predict if a customer is going to leave the bank. And to do that, your advanced analysts, your data scientists would sit and sift through data, trying to find those variables that are important to churn. So is the tenure of the customer important to churn? Is the age of a customer important to churn? If they were looking at, is a customer going to buy a new mortgage? They might look at how many children does that customer have? What's their salary? What's their income? Is that a good predictor of a customer looking for a mortgage? So as they sift through these variables, they would identify the 8, 10, 15 variables that were most predictive, feed them into a machine learning model, and it would give them an answer. So is this customer likely to churn, yes or no? And actually, as a data scientist, you're looking at the statistics and you're looking at the fact there's an 80% chance of this customer churning, and then you might make a decision one way or the other. But if we reflect back on what I described around the big data sphere, now that we're collecting every single interaction a customer has on any channel, the amount of data to sift through has completely exploded. So as a quant, as a data scientist, you no longer have 5, 10, 20, 30 variables or 50 variables to sift through. You've potentially got 50,000 different variables that might be a predictor for churn, that might be a predictor if a customer is looking for a new mortgage, and so on. And this data is coming at us at speed. It's complex. These interactions are not simple. A single interaction on its own might not have meaning, but in a customer journey, if you look at several interactions together, they begin to paint a picture. They begin to tell you what that customer is thinking. And more importantly, today, with the business wanting to have these real-time interactions, this real-time dialogue, they need to be able to have insight within their hands within seconds and minutes, not hours and days. So traditionally, a great analyst might be able to create a couple of models a week. Today, we're looking to really scale that out and have hundreds and thousands of models running across our organization. And this is where these buzzwords come in. This is where the machine learning, the deep learning, the AI techniques really come into play. So today, we see that with all of this data, these granular interactions, we can actually feed these to the machine learning algorithms, to the deep learning algorithms, and there's enough data today for these algorithms to make good predictions. Now, in fact, these algorithms are not new. As you heard from the previous speaker, these algorithms have been around for a long, long time. But the key difference today is we have that data. Previously, when big data, when all of these interactions weren't being collected, we didn't have the data to feed these algorithms. But today we have that data. And in fact, today machines, the code, the algorithms can make a much better decision than a human can because there's far too much data for a human analyst to be able to sift and make sense of. And the other difference is today we have the compute power to be able to run these algorithms at scale. We can run these algorithms across billions of data points for our 100,000 or million customers at scale. So let me give you a practical example. So talking about that churn use case, we worked with a number of telcos in this space, and as a telco provider, if you're Vodafone or you're Three, you are looking at customers who are churning because churn is a key problem. If you lose a customer, it's really difficult to win them back. So a traditional model would have looked at, how many calls is a customer making, what's their ARPU value, what's their spend, etc. But for a lot of the telcos, they want to now change the way they look at churn and look at behavior. Is there something that we're doing within the customer's journey that the customer doesn't like? Is it related to the experience that the customer is having? So is it a case that the customer had lots of dropped calls, they're receiving poor network coverage, they called into the call center to complain, they weren't happy with the service, and that journey led them to churn? So if we completely change our paradigm in terms of looking at this problem, rather than building a traditional predictive model, what we can do is we can take all of these interactions that have taken place in customers' journeys, and we can knit these together. We can look at a customer as they move across channels. So in this case, we had 2.6 billion events over 5 months of data for customers interacting across 13 different channels. Too much data for a human analyst to sift through, but we can feed this to a machine learning algorithm. We can feed it to deep learning algorithm because these algorithms are now able to detect the important features. So these algorithms are able to look at the combinations of events and find which combinations are important. Okay, so that call into the call center on its own was not predictive of churn, but the fact that you couple that call to the call center with an email that was received with lots of poor network coverage recently, these events together begin to be highly predictive of churn. So as these algorithms begin to model a complex series of combinations, they can begin to sift through this data and identify the important features that a human analyst couldn't. They can automate that labor-intensive feature engineering that a traditional analyst would have to do. And in this way, what these algorithms are allowing us to do is move away from this descriptive world of looking at our customers as a set of statistics, as a set of demographics, to really thinking about customers in terms of the behaviors that they're exhibiting, in terms of the intention that customer has, in terms of relationships between customers and the influence of those relationships. So really, these algorithms are helping us identify where in that journey we should intercept within a customer to change the course of that journey. They're helping us be there for that customer at the right time within that customer journey. But being there is great, but being useful to that customer within that journey is also essential. So having a real-time interaction, but ensuring that what you're speaking to the customer about is relevant to that customer. So the second example that I have here is from a use case that we've done with several retailers. And for retailers, a common use case or challenge is having a digital estate where customers can actually come and find what they're looking for. So many big digital retailers will have their website estate where they have a catalogue of hundreds of thousands of products that customers can come and browse. Yes, customers come and browse those catalogues, but often customers will perform a search, especially when they're coming for a targeted product that they're looking for. So retailers know that that search functionality is very important to get a customer to the right product. But actually, if we look at the data, the majority of customers who perform that search only look at the first search results page. They don't make it to page 2, 3, or page 20. Hence, making sure that the product that the customer is looking for is on that first page is really important to improving conversion. And in fact, if that product doesn't appear above the fold on the page to what the customer can see, you don't know the customer will scroll down to the bottom of that page. So making sure that the product that you want that customer to see that the customer is looking for is either product 1, 2, or 3 is really important. But with retailers in this space, what we found is often when you go to a website and you look at some of the searches that have been performed, they don't perform very well. So here is a search that was performed by a customer who came to this retailer's website and they'd typed in toddler long sleeve shirt. The website gave this customer 0 search results. And this is because the traditional way of matching a customer's search with a product is by matching on keywords. So when a product catalogue is uploaded onto the website, each product will come with a set of keywords, and if the customer uses the right keyword to something that's in your catalogue, it will appear. But what we're relying on here is for the person who has tagged those products to have thought about all of the combinations of keywords that a customer might search on. And in this case, toddler long sleeve shirt were not the words that products were tagged with. So in fact, if you looked in the catalogue, there was a number of relevant products that should have been returned and displayed to the customer, but in fact, there were no products returned to the customer. So again, using neuroanalytical techniques that are available to us today at scale, we can think about this problem completely differently. So rather than relying on this static keyword bank that's associated with each product, what we can do is we can go back to those hundreds of thousands of web sessions that have taken place on the website. We can take that history of web activity, we can look at all of the searches that were performed by customers, and we can actually look at the words that customers were using to search. We can look at the words the customer used to search, and we can tie them to what activity happened. So what did the customer actually go on to browse? What did they actually go on to buy? Because presumably the words that they were using were the keywords that they were thinking about when they wanted to buy that product. So as we look at that history, that really rich history of web searches, we can begin to do natural language processing. We can build various models using a number of different techniques that then allow us to associate the language that the customer is using with the right products in our catalogue. And overall, this improves the relevancy of the searches. So when a customer comes to the page, you're showing them the right products, and it improves conversion rates. So in a couple of cases here where we've executed this use case, we've seen up to 25% improvement in conversion rate from searches that are happening on the website, just because we're getting the most relevant products in front of the customer. So being there is important, but being useful with the right product, with the right message, the right service is essential to being successful. However, the last element of that Google meaningful moment is be quick. So yes, having the right creative, having the right narrative, identifying the right customer is great, but you also need to be quick. With the variety of choice that consumers have today, all of these channels, if you're not there, somebody else will be. So being quick is important, and a great example of this today is programmatic ad buying. We're all familiar with, if you've been online, if you've been searching for products, or you've been searching for flights, you will begin to see those targeted ads. And the research has shown that the better that targeted ad can get in terms of what you've been browsing, the higher chance that you're likely to respond to that ad. But to really get targeted with an ad is not just one model running behind the scenes. We need to have hundreds, thousands of models running behind the scenes, looking at what a customer's been browsing, looking at what products are available in the catalogue, looking at if there's stock within the warehouse of those products. Is the price, what's the price? Is that a price that the customer is willing to pay? Thousands of models running in the background to determine what's that right ad to display to a customer. And the key is that ad needs to be served back to the customer in under 15 milliseconds for it to be relevant, highly relevant to that customer. So we see this idea of real time, being quick as key, as very important. And I pulled out a use case that we did with a large advertising agency that brought home how quick our models need to operate today. So this advertising agency, they work with billboard campaigns, and they wanted to look at how they could use analytics to make a very traditional medium, the billboard, much more relevant to those consumers, to those potential customers, to the people on the road. So what the idea that they had is to take video camera footage from the side of a motorway and to analyze that footage. So what they asked us to do was analyze that footage, and from that footage be able to detect vehicles, but detect the make and model of that car. Because if you can detect the make and model of that car, you can begin to update those billboards in real time to make them more relevant to the person driving that vehicle. But of course, for this use case to work, we had to have real-time analytics running to be able to do the image analytics from that video to detect the make and model of the car, but also analytics to make sure we can match an offer to that vehicle and have that offer on the billboard before a customer drives by. So response times are key. And we're seeing this across industries in many different use cases, that we need to be able to analyze the data that's coming through, this complex interactions at speed, at scale, and we need to be able to make decisions that reach customers. So no longer is it viable to have a human, to have a marketeer in the loop making a decision if a customer receives a campaign or not. We have to have machines making those decisions, so automated decisions. But actually, as we begin to think about putting these models into production, we see how difficult it is. So working with the analytical teams, our customers, speaking to a number of data science teams, I see that, you know, many of the large organizations out there have challenges putting models into production. It takes potentially years. A lot of models don't ever make it into production. And even when they make it into production, these models need continuously refreshed because they become stale. The environment changes. If they're not refreshed with new data, that model's outputs degrade over time. So I go to the example of industrial manufacturing, because we can learn from industrial manufacturing about how to potentially pipeline our models, to put our models into a production scale factory. So if I take the example of Lego, Lego are a company who produce toys. They produce toy bricks. And they are producing a premium price product. And to enable that premium price, they have to ensure that on the production line, they have good quality, high quality to ensure the product that they're producing remains premium. So for Lego, what they do is they put a whole measurement framework in place. So they're looking at things like the depth of the brick, the width, the height of the brick to ensure it's made to specification, but they're also testing the outcome. So when a child comes to play with that brick, it is suitable for purpose. So pressure tests, because a child should be able to put two Lego bricks together, but also pull them apart. They do bite tests, because inevitably children at play will put toys in their mouth. So they're testing the outcome that they're enabling through these toys. We can apply a similar concept to our models, because as we begin to put these models into production, we want to have a measurement framework around these models that allows us to manage them, to monitor them over time, to see if they're still performing as we expect. So we want to schedule these models, we want to monitor them, we want to look at the statistics. So what's the false positive rate, what's the p-value, what's the F statistic, etc. But we also want to measure the outcome. Is that model still giving us the response rate we expect? Is it still giving the lift that we expect? So on and so forth. The conversion rates. Is it still reducing churn? And so on. And if we can automate this, if we can really find ways to put analytics into a factory scale, we can have thousands of models potentially being looked after by a few analysts per year. And this is key, because if I look at many of our large customers today, they have the in-house data science teams now. They've hired those analysts who can build some of these models. But these models take time to manage. And if we don't put the automation in place, what you find over time is your data scientists become the engineers who are looking after these models rather than creating and innovating the new set of models, the new algorithms that will create the game-changing next step. So actually, reflecting on also the talk that came before, it won't be about machines working in isolation. Yes, we're putting automation into place, but we still need those analysts, we still need those marketeers, we still need those business people to work in conjunction with smart machines. So where machines are coming into play is they are beginning to automate some of the labor-intensive tasks. So feature engineering for data scientists, for analysts, is being automated. Some of the interaction with customers is being automated, but it is still the humans in the loop that are helping to engineer these models together, that are deciding what's the acceptable thresholds, and so on. So often when I'm speaking to at conferences or events or with customers, the question comes up, will machines replace the marketing function? Will machines replace analysts? That's simply not true. It will change the skill sets that we need as analysts. It will change the skill sets that marketeers need, that business users need. And I think an example that really drives this home is if we look past the history, is the ATM machine. Because when the ATM machine was introduced, there was lots of scaremongering that it would replace the job of a bank teller. And yes, if you look at ATM machines, when they were introduced, the number of tellers that you needed per branch did reduce. So on average, you initially had 21 tellers per branch, and that reduced to 13. But the consequence of that was branches were cheaper to run, so banks opened up more branches in more locations. But actually, significantly for the teller, their job role changed. Rather than being a cash handling entity dealing with customers, they became part of a customer relationship team. So this is what we need to reflect on in terms of machine learning in other business functions. How will it change the role of those business people within the organizations that we work in today? So to wrap up there, data is useful. Data creates value. It does create insight. But data is just the foundation. Collecting that data, holding it in a data platform, doesn't create value on its own. It's the analytics on top. It's the machine learning, the deep learning algorithms today that can really help extract maximum value from all of these interactions that you're collecting across channels. But in the future, what we're seeing as one of the big challenges is the automation of the analytics. Because it's no longer about creating that one model, 2 models, 5 models. It's about creating thousands of models that will potentially be running across your organization. Helping to create new products, helping to create new services, improving customer experience, improving business models. The possibilities really are limitless. Thank you.